So today we're going to be doing compounding interest, and we have two ways of compounding interest. Let me go back a page here. We have compounding non-continuously, and the words we're looking for, well, basically if it doesn't say continuously, it's non-continuously. But the types of investments that are compounded, the way they compound investments, they can do them yearly or annually. Then you have semi-annually, which would be twice a year. They can do quarterly, which is 4 times a year. They can go monthly, which is 12 times a year. They can go daily, 365 days a year, and so on and so forth. All right. So they can describe how they compound it. Interest is compounded daily. So now the number of times it's compounded, so that's affecting n. Yearly, n equals 1. Semi-annually, n equals 2. Quarterly, n equals 4. Monthly, n equals 12. Daily, n equals 365. How many days in a year, how many months in a year, how many quarters in a year, 4 quarters. Semi means half, so half a year, so twice a year. So they're going to describe a non-continuous compounding interest in some of these fashions here. They could go hourly if they wanted to. Minutely, secondly, all right, how many hours in a year, how many seconds in a year, how many whatever. So however they want to compound it, they can compound it. Okay? If I'm not doing a continuous compounding interest, here's my formula. The amount of money I put into the account, the amount of money I end up with. P is what I put in, A is what I end up with. R is the interest rate as a decimal. N is whatever N is based on these descriptions here. And T is how many years it's in there. All right? A continuously compounded interest formula. P is how much we start off with. A is what we end up with. R is the interest rate as a decimal. T is the number of years. E is the second LN button on most calculators. It's just a magic number that exists in the world. Okay, you guys have worked with circles before. You've done the area of a circle, or the circumference of a circle. You have 2 pi r, and pi is just a magical number that exists in the world that you maybe at some point learned about. That is the ratio of the diameter of the ratio of the circumference of a circle over its diameter. That's what pi is. Take any circle and take the entire circumference, divide by the entire diameter. You always get the exact same number of pi. Well, E is found if you take this expression as n goes towards infinity. If you keep making n bigger and bigger and bigger and bigger and bigger in that expression, you're going to get to what E is. Let me demonstrate on a calculator. You don't have to do this, but I'm just showing you where it comes from. So if I try 1 plus 1 divided by, pick a big number for n.
20.
What? 20. All right. 20. And I go to the 20th power. It equals that number. Let's pick a bigger number than 20. 1 plus 1 divided by something bigger than 20. 45 to the 45th power gets that number. All right. Let's try a bigger number than 45. Let's get crazy. Let's get in the triple digits. Plus 1 divided by what?
5,000.
5. That's even better. 40 to the 5. I don't know if my calculator can handle this. Oh, it did. Okay, so 5,000 is rather large. If you start getting bigger than that, it might start going haywire a little bit. If I hit my second log button, e to the first power, first power, you can see they're about the same number. All right. So again, e is just a magical number that exists in the world. If you take that expression, let n get bigger, 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 you're going to eventually get to this number right here.
Is that LN?
ln, yes.
Where would that be at on our calculators?
On these calculators, let me see. Oh, right above the PRB button right here, it's third row, third one over. PRB, it says LOG above it. Hit the second LOG, and then right over there it's LN. You have, say, slide over a little bit, so kind of roundabout, but you have to hit the second log button, so second PRB. That's on these calculators. Hit the second button, then hit the PRB button. And it brings up a screen that looks like this, LOG 1, LOG 2, 10 caret parentheses, and then LN 1, LN parentheses 2, E caret parentheses. All right, it gives you like this. So whatever your so you have to hit left and right to choose whichever one. So you would want to hit the second PRB first. Takes you to this. It's going to be in the log. You want to push to the right to get to here, and then choose that. All right. And there's just tabs at the top. One tab is log, the other one's LN. You want the LN if you have to use the E to a power. All right. So these are your formulas. Again, this is the formula here for non-continuous compounding interest. This is the formula for continuous compounding interest. And everything you need to know about those formulas is right there in the list. So basically, they're going to tell you some of the stuff, ask you for the other thing. And again, this piece of paper was just handed out to you, so you don't have to.
Could you maybe zoom into the purple part?
This part?
Yeah.
There you go.
Or is that the second one is semi?
Semi-annually,
Okay.
quarterly, monthly, daily. N equals 1, 2, 4, 12, and 365. And those aren't all that are there. That's just an example of a list. But again, they could say hourly, then you have to figure out how many hours there are in a year. 365 times 24. You know, it's just, you know,
Is that quarterly?
quarterly, yes.
Or-
Everybody good? All right, so if we look at example 1, Tamira invests $5,000 in an account that pays 4% annual interest. How much will there be in the account after 3 years? The interest is compounded annually, semi-annually, quarterly, or monthly. So that, basically this is 4 problems in one. All right. The first one, it wants compounded annually. Compounded annually, that means that n equals 1. Then they want us to compound it semi-annually. That means n equals 2. They want us to compound it quarterly. That means n equals 4. And then they want us to compound it monthly. That means n equals 12. So again, 4 problems. Everything stays the same except for the n value. All right, so for each problem, I'm going to change what n is. Everything else stays the same. As far as everything else is concerned, we're investing $5,000. That's called our principal. When you invest money in an account, the amount of money you invest is called principal. Okay. Pays 4% annual interest, so that means the interest rate is 4%. What's 4% as a decimal? 0.04. Be very, very careful that you move 2 decimal places over. If you make it 0.4, now you're looking at a 40% investment, you're going to be making too much money. Okay? If you find a bank that doesn't know how to work with percents well, and they give you 40% on your investment, that's a good bank to go into. But if you're running the bank, you'll be in trouble because you run out of money real quickly. So, but again, 4% is 0.04. Make sure that you go 2 decimal places over. Do not go 1 over. All right, so 0.04. And then we're keeping the money in the account for 3 years. T is the number of years. And they're asking us for what A equals in each of these 4 scenarios. So let's just call this problem A, B, C, and D, just to be able to distinguish between them. So I'm looking at problem A. None of these say continuously, right? So every one of these problems, I'm going to use the exact same formula, which is the final amount in our account equals what we invested times 1 plus r over n to the nt power. That's our formula. We know all the numbers over here. P is 5,000, R is 0.04, N for part A is 1, both N's are 1, and T equals 3. So for part A, my final amount of money is going to equal 5,000 plus 1 plus 0.4 divided by 1 to the 1 times 3 power. I'm going to type that exact expression in my calculator. Now be careful, 1 times 3 is a product, so make sure that when you hit the caret key that you have to have the product in parentheses. So I'm going to type like this. I'm going to type 5,000 parentheses. 1 plus 0.04 divided by 1 and parentheses. I'm going to put caret and then parentheses 1 times 3 and parentheses. My calculator cannot think. It can only do what I tell it to do. If I don't put the parentheses around the 1 and the 3, it's going to raise it to the first power and then multiply the answer times 3. So caret parentheses 1 times 3. Obviously 1 times 3 is 3, right? So I could have just easily put parentheses, or caret 3, right? But sometimes the product isn't as easy as that. So just know that if it's some unpleasant product, parentheses, product, and parentheses for the power. Hit equals. After 3 years, we should expect to have $5,624.32. When we're dealing with money, round to the nearest cent makes sense. So, no pun intended. The final amount of money in our account is $5,624.32. Again, that's compounding it annually, once a year. All right. If we go semi-annually, part B, same exact formula, except now n equals 2 instead of 1. So now A equals 5,000 times 1 plus 0.04 divided by 2 to the 2 times 3 power. Notice for part B, n equals 2, n equals 2. Notice what it did to the interest rate. It was a 4% interest rate. Now it's half as much as 2% interest rate one time and a 2% interest rate the second time. It's compounded twice in the year, but you only compound half as much interest each time. So you're compounding it more often, but at less amount. So that's how they kind of affect each other. Get back to my calculator here and type in, again, I'm going to type in exactly what I see. 5,000 parentheses 1 plus 0.04 divided by 2 n parentheses caret parentheses 2 times 3 power n parentheses equals. That gets us $5,630.81, round to the nearest cent. $5,630.81. Notice an extra $6.49. Just by them doing it twice a year at 2% each half year, as opposed to doing it once a year at 4% every year. Okay, our part C. N is equal to 4. So the amount of money we're left in the account with is going to be $5,000 times 1 plus 0.04 divided by 4 to the 4 times 3 power. Again, all I'm doing is changing the value of n. N is 4, N is 4. Everything else stays the same. Get my calculator. Come over here and type in what I see. I got 5,000 parentheses, 1 plus 0.04 divided by 4 to the parentheses 4 times 3 power. $5,634.13. That gets us an extra about $3.50 over the semi-annually, and it gives us an extra almost $10 over the annually. And finally for part D, now we're going monthly, n equals 12, so A equals 5,000 times 1 plus 0.04 divided by 12 to the 12 times 3 power. Notice that I've changed n to 12. Grab my calculator, punch it in, 5,000 parentheses 1 plus 0.04 divided by 12 end parentheses to the parentheses 12 times 3 power end parentheses. 5,636.36. Couple dollars even more than the other one. Each time we compound more frequently, we get more money because, again, you're basing the interest on the previous amount. So you're bumping the previous amount up each time incrementally, so the amount you're increasing by is more. So that's how it works. Do not, and I stress this, do not try and type this, don't like go 0.04 divided by 12 equals that and then round. So don't go 5,000 times 1.0033 to the 36 power. Oops. To the, sorry, 12 times 3 power. See, it modifies the amount of money. So again, don't allow the rounding to happen. So again, type in what your formula shows you to type in. Don't try and simplify it down to something and start rounding in your work. It causes your answer to be way off. So make sure that you're careful with that.